Alright, I want to look at a few common expressions that students oftentimes get mixed up on how to treat these algebraically, and we're just going to look to see whether these supposed identities are actually identities or not, or are they uh, just contradictions. So first of all, we have a plus b quantity squared equals a squared plus b squared. Can you distribute the square? The answer is no, you cannot do that. You cannot. Why is that? Because if I take a plus b squared, so that's a plus b times a plus b, that's actually a squared plus 2ab plus b squared, right? Remember, you have to FOIL it. So you get a squared, ab, ba, so that adds up to 2ab, and then b squared. And that is definitely not a squared plus b squared. Okay, so this first one is not an equation, or not a true equation, a true statement. Okay, for part B, square root of AB equals the square root of A times the square root of B. We are going to say true. This does work. Why is that? Because this is A plus B to the 1/2 power, which is the same thing as saying A to the 1/2 power times B to the 1/2 power. So we're okay with that. That works. Alright, part C. Square root of A squared plus B squared equals A plus B. And we're going to say that is not true. No, you cannot distribute a square root. In the same way that part A doesn't work, you can't distribute a square, you can't distribute a square root. Right? This is the same. This is A squared plus B squared all to the 1/2 power. That's not the same as saying A squared to the 1/2 plus B squared to the 1/2, which is what they wanted us to say. Okay, on the next one, before I say whether it's true or not, let's try to see if this works. Let's multiply the c. Let's multiply both sides of this equation by c. And so when I do that, I end up with 1 plus tc equals c plus tc. Okay, so from here you can see that in general this is not the same thing, except I have one thing we should mention: unless c equals 1. If c equals 1, then we actually do get the same thing. So this shows up a lot where students will say something like this. You have x plus 7 over x, and they want to cancel the x's and just end up with 7. Oh, and that's really not good. You cannot do that. So the only time you can cancel is if you have the same factor in everything. Okay, so if I had x squared plus 7x plus over x, I can factor out an x out of every single term and end up with x plus 7. Okay, that does work. That would be good there. But this first one you cannot. In the same way with D, you cannot just cancel out that C. Okay, moving on to the next one, E, we have 1 over A minus B equals 1 over A minus 1 over B, and we are going to say that is not true at all. So in general, if I'm subtracting fractions, the denominators don't work in this sense, right? If you're adding or subtracting fractions, you have to get common denominators first. Okay, so that doesn't work. All right, this last one, 1 over h divided by a over h minus b over h equals 1 over a minus b. We are going to say true. Okay, so this goes back to the factoring thing, and you wonder, well, what can we factor here? I noticed that there's this over h in all my terms here. So what I could do is take out a 1 over h out of my numerator and my denominator. And when I do that, in the numerator, I'm just left with a 1. In the denominator, if I take out a 1 over h out of this first term, I'm left with an a. And out of the second term, I'm left with a b. So I have 1 over h times a minus b. And if you notice, then I can cancel out the 1 over h's and left with 1 over a minus b. Okay, so that does work. Great. I hope this clarifies some mystery about algebra. Algebra is not magic or witchcraft or alchemy. The rules are consistent, even though students sometimes feel like they're not. If you have any questions, please let me know. I'd be glad to clarify. And thanks for watching.